Hi all, we got a great question about this function, this piecewise function here. So I thought I'd kind of walk you through how I graph a function like this. So what this piecewise function is telling us is that our domain is split into two pieces. And we're going to be using this first function for all of our x values that are less than or equal to 0. So this part of our x-axis. And we're going to be using our second function, 1/2 x plus 2 for the other half of our domain anytime x is greater than or equal to 0. So what this means, if we were, say, making a table of values for this function, and we were picking some x values, and when you're making a table of values, you can pick whatever x values you want. These are linear functions. The domain of both of them, before we have those little restrictions on there, is all real numbers. So we don't have any issues really in this class. The only time we have issues with domain is when we have square root functions. Those have issues, but these don't. We can plug in whatever numbers we want. And, I like to plug in things like, -2, -3, 0, 1, 2, 3, to get a good sense of what's going on. And I kind of also tried to pick an equal amount of points that are from that part of our domain that is less than 0 and from that part of our domain that is greater than or equal to 0. So when we're plugging in, things like -3, that's going in this first function because we use this anytime x is less than 0. So we get negative of -3 plus 1. So we get +3 plus 1, which is 4. And then we can keep going. -2 is still less than 0. And on this one, we get 2 plus 1, which is 3. We start to see the pattern there, and that gives us 2. Now, when we do get to 0, that's where we switch to our other part of our domain, our second part of our domain, when x is greater than or equal to 0. So these points we plug into our second function. And so when we plug in 0, we get -2. Oh man, I didn't mean to do 1 because that's going to give us a fraction. That's okay. We can do that. Generally, when I have a fractional slope, I like to pick numbers that are multiples of the denominator because then I don't have fractions as answers. We'll see that here in a second. So we get -1.5 there. So here's an example of a number that is a multiple of our denominator, a multiple of that denominator too, because when we do 1/2 times 2, we get 1. And so we get rid of that fraction, which is really kind of nice. So maybe instead of plugging in 3, let's plug in 4, because 3 is going to give us another fractional answer, which is not we can still graph that, but it's not quite as easy as when we get 1/2 times 4, which is 2, minus 2, which gives us 0. So what we've got is now several points on this graph. We've got -2, 4, or sorry, -3, 4, -2, 3, -1, 2, and then we've got our other points, 0, -2, 1, -1.5, 2, -1, and 4, 0. So I'm going to erase these highlights over here and draw these in the individual colors here. So -3, 4, that's going to be right about there. -2, 3 is going to be about right there. -1, 2. Now this line, it goes all the way until x is just right before 0. So I don't stop here. That's not our stopping point at this point right here, because we can plug in 1/2, we can plug in 1/3, we can plug in 1/9, we can plug in 1/1000th. So what I often do with this equation where we switch from our first function to our second one is I will plug in that value of 0, even though it's not included with that first function, but that's where that first function ends. It ends at the point 0, 1. And I'm going to draw that with an open circle because that tells us it's not included in this graph, but we go all the way up until that point. And then if we draw our line There we go. And so again, that's why I kind of picked, 3, 4 points, because then I actually see, exactly what my line looks like. And then the blue line picks up right here at 0, -2, and this has got a filled in circle. And again, this is why this is really important to have that open circle up here on our pink graph and a filled in circle down on our blue graph, because we need to pass a vertical line test. If they're both filled in circles, we're not going to pass that vertical line test. So let's see, oops, I switched to the wrong color there. 1, 1.5, -1.5 is about right there. So 2, oops, boy, a little off there. There we go. 2, 1 is right there, and then we have 4, 0. And then we've got this line. So the domain of this, again, when you're looking at domain, you're looking at, what parts of the x-axis do we have a graph? So if I go to any place on the x-axis, if I go up or down, will I hit a graph? Absolutely. Every single point, and particularly right here, I only hit that blue point. That pink point is a circle. So our domain is all real numbers. And you can always write that as, whoa, handwriting is bad this morning, all reals. Or we can do that -infinity to infinity. And if we're then also concerned about, what our range is, that's again the y values where we actually have a graph. So I'm looking at the y-axis here and thinking about when can I go left or right and I hit a graph here, down here. I don't hit a graph going either way. But here, once I get to -2, there I'm hitting a graph. When I'm going to that way, here I'm hitting a graph. So I'm always hitting a graph going left or right. So that tells us that our range, it starts at -2 and it's everything bigger than that. So it's y is greater than or equal to -2, or in interval notation, -2 to infinity. And then what's our question? The last question is, does it have a y-intercept? It absolutely does. Our y-intercept is where it crosses the y-axis. Whoops, I forgot that. I just wrote that range there. I thought I was just going to erase my highlights here. Sorry, whoops. Guess I can't erase them all without erasing the axis there. But our y-intercept is where we cross the y-axis, which is right there. And that is when our x is equal to 0. When x is equal to 0, we use this second function. So our y-intercept is our point 0, -2.